Welcome dear student, welcome to my channel Talking Physics with Piyas Sarkar. In the previous day, we shall learn about the kinematics, that is motion in a straight line chapter, basics, some terminology, that is average velocity, average acceleration, instantaneous velocity. But today, we shall go with the main chapter topics, the topics of the main chapter, that is equation of motion. So, if I say you that, do you know the exact time of a certain distance reach or the total time of any distance covered? How can you get the total distance, total time, the velocity at that distance, the velocity, initial velocity? So, you know that we can find out easily this by some equation, okay, but we can know that the some equation, that is V is equal to U plus AT. Number 2 is S is equal to UT plus half AT square. Number 3 is V square is equal to U square plus twice AS. And number 4th is Sn equal to U plus half of A twice n minus 1. Now what is this equation means? You know this, that V is the velocity after time t, U is the initial velocity at time t equal to 0, and V is the velocity at time t, S is the total distance, and Sn is the distance in nth second, distance travelled in nth second. What is the difference between S and Sn? Now, if you go a distance in 5 seconds, so S is the total distance covered in 5 seconds. But Sn is after 4 seconds or in between 4 to 5 seconds, the distance covered in the 4th to 5 second, that is in the distance covered in 5th second, is written as S5. Okay. So S5 is the distance travels in Tth second, that is 5th second or 4th second or 3rd second, but S is the total distance in total time. This is the main difference between Sn and S. So, the relation will be proved in different manner, in algebraic way, in graphical way. We shall do in graphical way in my next video. We shall discuss the details about all the graphs and proof of the equation of motion. So, the easiest way, if you know the method of integration, then it is the easiest way to prove such of this equation. So, please give a look and stay my channel. So, we here use only the basic relation of integration, that is integration x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So, we can get with the first equation proof V equal to U plus AT. Don't skip my channel. I will say some very important questions of MCQ in between my lecture. So, V equal to U plus AT. We know that the acceleration A is given by dV dt. So, A dt is equal to dV. Now, we take the integration, that is integration 0 to t integration u to v, that is when time t equal to 0, the velocity is u, and when time t equal to t, the velocity is v. So, we can get at equal to v minus u. We know the integration of a to b x. So, we can get x dx, we can get it that x square by 2 a to b, that is upper limit minus lower limit, that is b square minus a square by 2. So we can get v minus u equal to at or v equal to u plus at. Now from this equation we can easily prove the equation of the motion of the second equation motion, that is s equal to ut plus half of at square. So let us do the proof. We know that velocity v is written as ds dt. So we can get ds is equal to v dt. Again do the integration. What should be the limit of the integration? We know that at t equal to 0, the distance covered is 0. At t equal to t, the distance covered is s. But here we shall put in place of v equal to u plus at. So integration 0 to s ds equal to u plus at integration 0 to t dt. So here we can get s minus 0 or s equal to integration 0 to t u dt, that is u t, plus a integration 0 to t dt. So we can get s equal to ut plus this equation is t square by 2, that is a t square by 2, that is half at square. So s equal to ut plus half at square is the formula if my initial velocity is u and if any body moves with uniform acceleration a, so s is the total distance in time covered by in time t. So we can now go with the third proof, that is v square is equal to u square plus 2as. V square is equal to u square plus 2as. So how can I prove this? Again here we prove v square equal to u square plus twice as. Okay, so we can again say acceleration a equal to dv dt. Okay, so we can write it as dv ds dt. Okay, dv ds dt. So the original value dv dt is unchanged. Now ds dt is equal to v, so we can write it as v dv dt. So we say that v dv equal to a dt. V dv equal to a dt. Sorry, v dv ds. V dv ds. Sorry. Or a ds. A multiplied by ds, or v dv equal to a ds. V dv equal to a ds. So when s equal to 0, when t equal to 0, v equal to u and s equal to 0. When t equal to becomes t, the velocity v becomes v and s become s, which means when this time t equal to 0, the velocity, here v means velocity, equal to u and the distance travel is 0, because at time t equal to 0 distance is 0. But when the time is equal to t, the velocity becomes v and distance travel is s. So we can get the integration limit value is from v dv, we can get that u to v at time 0 to s. Okay, u to v, because here time factor is not concerned here in the equation, so you cannot write the time. So if we take this equation is v square minus u square divided by 2 is equal to a s, or v square minus u square equal to twice a s, or v square equal to u square plus twice as. How easily it can be proved? Okay. So this is also the relation to find out the distance when time is not known. So v square equal to u square plus 2s, if the particle is go with uniform acceleration, then it is v square equal to u square plus 2s, and if it is uniform retardation, then it is v square equal to u square minus 2s. So now we go with the fourth proof, that is the distance travelled in nth minus distance travelled is nth second. If a body move for 30 seconds, therefore if we have to find out the distance travelled in 15th second, not 15 second, 15th th, then what will be the equation? So the distance travelled is nth second is Sn equal to u plus half of a twice n minus 1. So we know that velocity v equal to ds dt. Now ds equal to v dt or u plus at dt. Now at t equal to n, distance travelled is Sn, or at t equal to n minus 1, that is 1 second previous the time t, distance travelled is Sn minus 1. So here we can take the integral from Sn minus 1 to Sn, and here we can take the integration from n minus 1 to n. So we can take ds, that is integration of ds is s, that is Sn minus Sn minus 1 is equal to u dt, means ut, that is u in time ut, that is u n minus 1 plus integration at, that is at square by 2, that is a by 2 n square minus n minus 1 square. Just put the value of t. So we can get Sn minus Sn minus 1 equal to Sn minus Sn minus 1. You can write it that at time t equal the distance travelled is n, is s. You can write it as s minus Sn minus 1, or s minus Sn minus 1, that is if u into n minus n plus 1, that is 1. So we can get it at u plus a by 2 n square minus n square minus 2n, that is plus twice n plus 1, that is minus 1. So we can get s minus Sn minus 1, that is the distance travelled in time n is s, distance travelled n minus 1 is Sn minus 1. We can write it as Sn equal to u plus half of a twice n minus 1. If we write it as Sn, then you can write in what the distance travelled is Sn dash or something. Okay. So in this way you can prove the whole equation by integration method very easily. Okay. Now we go with some numerical example. So I say you that I will ask you some question that if a particle goes with the uniform velocity, has it acted upon by any acceleration or not? What is your answer? Please write in my comment box. Is the particle moves with uniform acceleration, what is possible to have any acceleration of the particle or not? If yes, then write out the answer. Okay. So we can go with some example, that is, this is like a train. If this is platform and a man is standing behind the train about 9 meters. So when the train is start to leave the station, a man is running to catch the train. The distance between the train and the man, is 9 meters, and the train leaves the station with an acceleration 2 meters per second square. So our question is, how far does the man go to catch the train? Number 2 is distance traveled the man to catch the train. I hope you will understand the problem. When a man is 9 meters away from a train which is just leaving the station at a uniform acceleration 2 meters per second square, so how far does the man go to catch the train, and distance travel the man to catch the train? So basically we can find out the t and the value of s. Okay. Let us take that v be the velocity at which the man can catch the train, equal to the velocity of train. V be the velocity at which the man can catch the train, which is equal to the velocity of train. So the man, as per the condition of the question, the man has to go this 9 meters plus the distance travelled by train. So let x equal to the distance travelled by train in time t. So we can write it as 9 plus x equal to vt. Okay, vt is the velocity of the man in time t. The distance travelled by the man is vt, and in the meantime the distance travelled by the train is 9 plus x. Now again we can write that x for the train, okay, for train, x equal to 0 into t, as the initial velocity of the train is 0, plus half a means 2, t square, that is t square equal to x, and v square equal to u square plus 2ax, we can write it as 0 square plus twice into x equal to 4x. So we can get the value that v square equal to 4x and x equal to t square. This is the basic equation of which can help me to find out the time and the distance. Okay. So put square equation 1 both side, we can get 9 plus x square is equal to v square t square. So 81 plus 18x plus x square equal to v square t square. Now we can get t square equal to x. So and v square equal to 4x. So in place of v square you can write 4x, in place of t square we can write x, that is 4x into x equal to 4x square. So we can get that, or we cannot 4x into x, we cannot square this, then also the answer will be found out. So we cannot square this. So from the equation 1 we can get 9 plus x equal to vt, which is v square equal to 4x, this v is root 4x, okay. So 9 plus x square equal to v square t square, that is 4x into t square means x. So 9 plus x square equal to 4x square or twice x square, okay. So 9 plus x square is equal to twice x square. So we can get 9 plus x equal to twice x, or x equal to 9 meter, okay. 9 plus x square equal to v square t square. In place of v square we can write 4x, in place of t square we can write x, then 4x into x equal to 4x square. We can write it as plus minus 2x square, okay. Write it as plus minus 2x square. So here we can get plus minus 2x square. So we can get the value of when x plus x, that is x equal to 9, and when it is minus x, then x equal to minus x minus 3x equal to minus 3 meter, which is impossible because distance cannot be negative. So we can get x equal to 9 meter. Now putting the value of x, we can get out the value of t, that is t square equal to x. So we can get the value of t. We can know that t square equal to x, which is 9, then t equal to plus minus root 9 equal to plus minus 3 second. As the time also cannot be negative, then t equal to 3 second. So basically the man will reach the train after 3 seconds, and in the meantime the total distance travelled by the man is 18 meter. In this way we can use the basic equation of laws of motion. So I hope you understand it. Next we go with a problem related to Sn, so that you can consider it very much, okay. So the problem is, these two problems are very important, okay. Please write down in your copy. So if x, y, z be the distance described by during the particle pth second, the particle travel in pth second, a particle travel in pth second is x, in qth second is y, and in rth second distance is z. Then prove that q minus r into x plus r minus p into y plus p minus q multiplied by z equal to 0. Okay. So solution. We can know that Sn equal to u plus half of a twice n minus 1. So pth second, the distance is x. So you can write x equal to u plus half of a 2p minus 1. Y equal to u plus half of a, as the particle go with uniform acceleration, 2q minus 1, and z equal to u plus half of a twice r minus 1. 50% work is done. Equation number 1, equation number 2 and 3. Now look at the proof. Prove that q minus r, from which we can get 2 minus 3. So if we take 2 minus 3, then what we can get? Y minus z equal to u will be cancelled, half of a, 2q minus 1 minus 2r minus 1, that is minus 1 plus 1 will be cancelled out. 2q minus r is, that is q minus r into a. So we can get that q minus r equal to y minus z by a. Q minus r equal to y minus z by a. Okay. Next, r minus p. R minus p means, what is our equation number 3 minus 1. So if we subtract equation number 1 from 3, then we can get r minus p, that is z minus x by a, again is given by r minus p, and p minus q, 1 minus 2, then we can get p minus q, x minus y by a equal to p minus q. Now just put the value of q minus r minus p and p minus q in the following equation, in the above equation. So what can we get? Q minus r into x. What is the value of q minus r? Y minus z. Y minus z by a into x plus r minus p, z minus x by a multiplied by y plus p minus q is x minus y by a to z. So we can get the total LCM is a, then we can get xy minus xz plus zy minus xy plus xz minus yz. So xy cancel out, minus xz plus xz cancel out, plus zy minus zy cancel, 0 by a, that is 0, proved. Okay, I hope you understand this problem. For doing such type of interesting problem, please watch my channel and watch the full video. Do not skip, or you will be miss very interesting fact, as I know, as I tell earlier. Okay, in the next day we will go with the motion under gravity for JEE and NEET 2023. If you like my channel, please subscribe my channel for this more interesting video. I 100% promise you that you will be benefited from it. Okay, so for today, thank you.